My name is Keshwani. It's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 176. Day 176. We are in the process of solving word problems from day 101 to 200, and today is our 76th day of solving a word problem. The problem is already on the blackboard. I'm going to read it to you. It says, how many workers will be required to do a certain job in A hours? A is some number of hours. How many workers will be required to do a certain job in A hours if we know that the B workers can finish it in A times C hours? Do what you have to do. Pause the video, do what you have to do, solve it, and when you have the answer you can resume it. Okay? Here's the solution. We are told that A times C hours are needed by B workers. Workers should have another R in it. Well, listen, before I go further with it, let me give you some numbers. We will do with the numbers and then we'll understand the concept and then we'll go back to our variables, okay? Because that's what it is. An algebraic problem is simply an arithmetic problem. Instead of having numbers, we have unknowns. These are numbers. We do not know how much A is, we do not know how much B is, we do not know how much C is. Because if we knew the value of A, B and C, it will turn into a simple arithmetic problem. So, for example, if we are told that 2 hours are needed by 3 workers. If you're told that 2 hours are needed to do a job, to get a job done by 3 workers, and if you insist that 2 hours is too long, I want the job done in 1 hour. Well, if you want to get it done in 1 hour, if you want to get it done in half the time, if you just want to get done in half a time, you better provide twice as many workers. 3 times 2. Similarly, if you're told that 5 hours are needed to get the job done by 3 workers, and you say no, 5 hours is too long, I want to get the job done in 1 hour. Well, if you want to get the job done in 1/5 of the amount of time, you better provide 5 times as many workers. One last example. If we are told that 10 hours are required to get the job done by 3 workers, and you say that no, I want to get the job done in 1 hour, in 1/10 of the amount of time. Well, if you want to get the same job done in 1/10 of the amount of time, you better provide me with 10 times as many workers. Same logic applies here, except we do not have numbers. We have A, B, and C. But those are numbers, those are unknowns, those are variables, and we do not know their values. So same thing here. If A times C hours are required, by B workers, and if you're hell-bent that the job be done in 1 hour, then you better provide me with, instead of B workers, you better provide me with B times A times C workers. You see, it was same as before. You see, there's no difference. Before we had, let's do one more example if you like. If 3 hours are required by 7 workers, so here your 7 is B and your 3 is A times C. A times C is 3. And if you insist that you want to get it done in 1 hour, then you need 21 as many workers. 3 times as many workers, because you want to get it done in 1/3 of the amount of time. The same exact thing is going on here. So before we needed B workers, now we're going to need B times A times C, or as an as a mathematician would say it, you need A times B times C workers. Let's carry on then. But the problem is, we do not want the job to be done in 1 hour. We are told how many workers will be required to get the job done in A hours. So if to get the job done in 1 hour you need this many workers, then to get it done in A hours you need For example, if for 1 hour you need 10 workers and you say, well, you can get it done in 2 hours, well, if you give me twice as much time, I need half as many workers. So if 1 hour, for example, if 1 hour requires 10 workers, and if you give me, instead of 1 hour, if you give me 2 hours, then in 2 hours, I only need half as many workers. If 1 hour is required to get the job done by 7 workers, then in 3 hours, I will need a third of the amount of workers. Well, you'll have difficulty getting a third of a worker, but you get the idea. Do you understand? The same thing is going on here. Here, we do not want the job to get done in 1 hour. We have up to A hours. So A hours are needed by B times A times C over A workers. And of course, the A will cancel out. A will cancel out. And you will end up with B times C. What is the purpose of this exercise? What's the purpose of doing problems such as these? To train your mind, to learn how to think when you have to solve an algebra problem. That's what it is. What we're going to do now is we're going to redo the problem by plugging in numbers for the variables and see what happens. In other words, we're going to do the same problem in an arithmetic way and see if this answer actually makes sense. The answer is B times C workers. Let's see if it makes sense. We're going to plug in numbers, okay? So here, the question is now going to read, how many workers will be required to do a certain job in A hours. Let's plug in a value for A. Let's pretend that A is 7. If 3 workers can do a job in 7 times 4 hours. So I'm going to redo the problem and we'll see what happens, okay? Watch what happens. So what we're basically doing is we're plugging in A, 7 for A, 3 for B, and 4 for C. So now the problem reads like this. So we know that 28 hours, 7 times 4, 28 hours are required by 3 workers. Well, if instead of 28 hours, if you want the entire job to be done in just 1 hour, you better give me 28 times as many workers. So 1 hour will be required by 3 times 28 workers. But instead of 1 hour, if you give me up to 7 hours, then for 7 hours, I need 7th as many workers. That's all. That's your answer. And of course, since we have 28 on the top, 28 is going to cancel out with 7. The same exact thing is going on. The A part, the A was 7. You see the common factor of 7 here. It drops out and we end up with 3 times 4. 3 times 4. B, your B here is 3. Your B is 3. And you C here, the B was 3. And the C is 4. 4, that's your C right there. You see, 3 times 4. We get the same answer. That's all. That's all it is. That was the end of the problem. It's a very simple, straightforward problem if you know how to handle it. And if you know how to handle it, this should be done. Something like this should take no more than 30 seconds, 40 seconds tops. That's all. But you have to train yourself for that. Do you understand? These kind of problems appear on a regular basis on the SAT and the GRE and the GMAT, particularly on the GRE and the GMAT. If you're preparing for those exams, you have to be able to manipulate variables in the simple algebra problem like that. Anyway, enough said. I'll see you tomorrow on day number 177. Alright? Bye now.